Question 7 has a particle projected with speed 4√5 at an angle inverse tan 1/2 to the incline. Okay, well let's start off getting our initial velocities here. Inverse tan of 1/2 given a √5 for the hypotenuse. Cos A is equal to 2/√5 and sine A is equal to 1/√5. So my initial vector is going to be 4√5 cos A 2/√5 in the I direction plus 4√5, and apologies in advance for the dogs fighting, but I don't get much time to make these videos, times 1/√5 in the J direction. So we end up with 4 times 2, which is 8i plus 4j. If we look at our accelerations in here, the tan of 45 in here, so we are going to have acceleration in the I direction of minus g sine 45, and it'll be the same in the J direction because sine and cos of 45 are the same, minus g cos 45, so minus g over √2 for both, minus g over √2 for the acceleration. So now, so what are we asked here? We're asked for using speed is equal to this guy, velocity squared of x and y. Show that the speed of the particle when it lands is 4. So I need the velocity of x and y when it lands. So v of x is equal to u plus at. So we have 8 minus g over √2 times t. So we need the time of flight. So when is s of y equal to 0 to get the time of flight? Put v of y in here as well for a minute. So when is ut plus a half at squared equal to 0? U is 4 and it's 4t minus, put the half in, times acceleration g over √2 times t squared. When is all this equal to 0? So factor out our t, we left 4 minus gt squared over 2√2 equals 0. So my initial time of 0 when s of y is equal to 0, and we'll have 4 is equal to gt squared over 2√2. So cross multiplying, we get 8√2 divided by, sorry, that should just be a t in there, not a t squared, divided by g will be equal to the time taken, the time of flight. So velocity of x, 8 minus gt over √2, v of x is equal to 8 minus g over √2 times 8√2 over g. They cancel. The velocity of x looks like it's 8 minus 8, which is equal to 0. Okay, let's look at the velocity of y. Jump back up, u is u plus at. 4 minus g over √2 times t, so it's the same. A g over √2, so 4, velocity of y, it's going to be 4, and it's going to be minus 8 again. We can see minus 8, which is equal to minus 4 meters per second. They're looking for the absolute value in the question, so the absolute value of the velocity is equal to the square root of 0 squared plus minus 4, if you want to put it in a bracket to be squared, which is equal to 4 meters per second. Thankfully, that's what we were asked to show.